Hey everyone, it's Patrick Morrison, and I wanted to make a short video to discuss a common misconception about deep sea hydrothermal vents or black smokers, and that is that they are self-contained ecosystems which aren't powered by sunlight. Now, this is only half true, and I say half because microorganisms which inhabit the vent power their growth and metabolism by reacting hydrogen sulfide and ferrous iron with dissolved oxygen in the water to produce sulfate and rust. While the sulfur and iron come from subsurface magma, the oxygen was produced by photosynthesis. So, this community doesn't really exist independently of sunlight. Now, there is carbon dioxide in the vent fluid, and when sulfur dioxide from the magma reacts with water, it produces sulfite. And in subsurface hydrothermal systems, microorganisms will react hydrogen with carbon dioxide and sulfite to produce methane and hydrogen sulfide as a means of generating energy. These systems do exist independently of the sun, but since sulfide will already be more abundant than sulfur dioxide, which will in turn be more abundant than hydrogen, the amount of energy available is very low. As such, these systems cannot support weird animal communities like deep sea clams and tube worms. But what are the broader astrobiological implications of this? Well, there has been a lot of talk about ice worlds with a subsurface ocean. Wandering, or rogue planets, exist in the vast expanse of space between solar systems, and if one is a gas giant, it can have a moon orbiting it. Should the moon be close enough, tidal friction will keep the interior warm, producing a subsurface liquid water ocean beneath an icy crust, with hydrothermal vents on the bottom. But without photosynthesis to produce oxygen, any microorganisms could only survive by reacting chemicals released by the vent, so we wouldn't see vent communities like we see here on Earth. But on the ice world that most of us are familiar with, Jupiter's moon Europa, the circumstances are a bit different. Jupiter's powerful magnetosphere catches energized particles which constitute the solar wind and trap them in radiation belts around its equator. Europa orbits within these radiation belts, and the high-energy particles split water molecules in the ice, producing molecular hydrogen and oxygen. The hydrogen flies off into space, while Europa has a very thin atmosphere of oxygen. Some of it percolates down into the ice into the subsurface ocean, again being kept liquid due to the tidal heating. Now, there are a wide range of estimates as to what the concentration of oxygen in Europa's ocean is, but it nonetheless raises the possibility that communities of chemosynthetic organisms and animal-like aliens may exist around deep-sea hydrothermal vents there. Well, that's all I have to say on the topic for now, but if you have an alternative view or something to add, I look forward to reading your comments. Thanks.